So this idea of radian measure, so it's another way of measuring angles. So instead of using the units of degrees, we use what are known as radians. And there's the conversion factor there. I mean, the conversion factor is actually 180 equals pi. But in my head, I remember that easier because I associate both with a complete circle, because 360 degrees is the amount in the circle, and when I think of circumference, that's 2 pi r, so I can associate those in my head quite readily with a circle. So that's how I've always remembered it, that 360 is 2 pi. So the common ones that we will see, you may have noticed in our last section on trig, those exact values come up a lot, 30 degrees, 60 degrees and so on. So these are the ones we will see a lot of and should recognise straight away. 30 turns out to be pi on 6, and then 45, pi on 4, 60, pi on 3. And this is where mathematics is mean. Wouldn't it make so much easier if 30 was pi on 3 and 60 was pi on 2? That'd be so much easier to remember. But of course it's not, because pi is 180, and 180 divided by 6 is 30. And so, all right. 90 then would be pi on 2. So there's our first quadrant. So in the second quadrant, the numbers we'll see cropping up a lot. 120 degrees would be 2 pi on 3. 135, 3 pi on 4. 150 is 5 pi on 6. And then 180, we get to pi. So there's our second quadrant. Our third quadrant, 210 degrees, 7 pi on 6. 225, 5 pi on 4, 240 degrees, 4 pi on 3, 270 degrees, 3 pi on 2, and let's complete the circle. Fourth quadrant, 300 degrees turns out to be 5 pi on 3, 315, 7 pi on 4, 330, 11 pi on 6, 360, 2 pi. Now obviously they're not the only angle measures that you can have, but we will see those results crop up quite frequently because they do like to write questions that come out with exact values as the answer. And I've got to be honest with you, when they ask me a question and it's in radians, in my head, still to this day, and how long have I been teaching? Gosh, a long time now. Plus when I was at school itself, I've just always converted it back into degrees and worked it out in degrees in my head. I just find it easier myself. So, 67 degrees, of course, is not one of those exact ones. How would we change it? Well, we multiply it by pi on 180, basically. So that conversion factor, pi is 180 degrees. So the pi goes on top when we want to turn into radians, and that doesn't cancel, but I've actually converted it to its number here just to illustrate how big a radian actually is. So 67 degrees is just 1.1693 radians. So 1 radian actually is quite large when you're talking about an angle. Okay, 36 degrees then, that one will cancel. So 36 goes into 180, we get pi on 5. And if we're going back the other way then, we'd multiply by 180 on pi. So pi on 8 radians, the pi's cancel, that's 22.5 degrees. Now, it doesn't mean you have to have pi in an angle that's measured in radians. You can still just have a number. So, for instance, 111.1 radians, and to convert it into degrees, again, we multiply 180 on pi, and we'll come up with the decimal approximation for that. And so, wow, look at that. 111 degrees is actually 6,365.6 degrees. Again, illustrating how large a radian actually is. Okay, that's all. So really that exercise is just on converting in and out and things like that.